Hello everyone, myself Dipti Gusse as Assistant Professor in School of Computer Engineering, Alandi, Pune. Today's our discussion topic is the deep learning algorithm for image and text dataset. In previous sessions, from session 1 to session 14, we have discussed the various deep learning algorithm for image classification, image feature extraction, image feature multiple object detection from the single images. Also, we have discussed the how to implement the NLP algorithm using deep learning algorithm. Also, we have discussed the time series analysis using deep learning algorithm. Now let us discuss about the basic concept of the deep learning algorithm. Now deep learning is nothing but the subset of the machine learning using neural network. Whenever we are using the machine learning algorithm, this statistical machine learning algorithm we can apply for the small data set. But whenever the data set in the form of text, video, images, in that case we need to use the machine learning algorithm using neural network. Now here, let us discuss few example of image and text data. Now the text data, whenever it is available in the form of sentences, paragraph, or in the form of scan copy, in this case we need to use the deep learning algorithm in different way. Also we can also use the images for the different purpose, like for classification, extract the information from the images, useful information from the images, to add the caption for the images. Now these are the application where we can use the deep learning algorithm for image as well as the text data set. Now objective of this presentation that discuss the algorithm for the image and text data set and explore the analysis, evaluation and comparison technique using deep learning algorithm. Now let us discuss dataset overview. Now here we can the image dataset like MNIST dataset, that is which is used for the handwritten recognition in the form of Marathi or different types of languages like English or different regional language. Now this MNIST dataset which will store the that is the English digit data set. Now using this data set we can explore the different types of deep learning algorithm for classification as well as the extracting information from the images. One more data set, that is CFAR10 data set, ImageNet data set. Now these are the other data set. Now ImageNet data set we are generally using for the pre-trained data. This is already pre-trained data set which consists of 1.2 billion images. The features of this data set, like these are the high quality images. The pixel intensity quality is good. The different color channels are available. Now let us consider for the MNIST data set there is only one color channel, that is a black and white image. But in CFAR and ImageNet data set there are different color channels like RGB, different object types of these images. Now let's next discuss the text data set. We are using IMDb data set, Sentiment 140 squad data set for the in deep learning algorithm for sentiment analysis, for predicting the next word. The features of this data set, passing through the deep learning algorithm through the word embedding, and we can extract the different types of contextual information from these text data set. Also we can apply the different types of natural language processing techniques to pre-process the data set. The deep learning algorithm used for the image data. Now convolutional neural network, transfer learning approach and generative models we can use for the image data set. Now the convolutional neural network architecture, this is the widely known algorithm. This algorithm which is used for the classification, and as well as we can use this convolutional neural network for the extracting the multi-object or detecting the multi-object from the images using YOLO model. Now this basic architecture of CNN consists of the different layer like convolution layer, activation layer, pooling layer, and every layer having their own significance so that they can extract the significant features from the images as well as perform the classification. CNN is also called as the feature itself as a feature extractor, as well as it is used for the classification. Next is the transfer learning. This transfer learning, this concept, this come from that pre-trained model. that is the already some pre-trained model are available. Through using this pre-trained knowledge weight or learnable weight, we can use this pre-trained model for our data set. If in this, if suppose there is a data set for the classification of vehicle, but that data set is not up to the mark, only few images are available in our data set. Now in this case, we can use the knowledge of the pre-trained model for the classification of our data set. Again, in transfer learning approach, there are two approaches. One is the feature extraction and another is fine tune approach. In feature extraction approach, we are extracting the feature using the knowledge of already pre-trained model, and using fine tune approach, we are tuning or updating the existing pre-trained model to improve the performance of our model with respect to our own data set. Next, last deep learning algorithm, that is a generative model. Now these generative model are like generative adversarial network, autoencoder, which are used for the image generation and image reconstruction. The example or application for the generative model to generate the images, face images, to improve the data set in our for our classification task. Or also we can remove the noises from the images. We can also generate the images from given input. Suppose I am giving my face image as an input, and then I can generate the images which are similar to my face image. These are the different application with respect to the generative model. Next, let us discuss about the deep learning algorithms which are used for the text data. The text data which consist of in the form of paragraph, sentence, pages, or in the form of scan copy. Now these data is collected from the different resources. We can collect the data resources from in the form of corpus, or in the form of news, in the form of paragraph. That paragraph we are taken from any context. Okay, now from these data set, or also we can collect data for the sentiment analysis. We can collect the data from reviews or different types of resources. Suppose teaching material is there with respect to any subject. Now these data is lot of data is available nowadays in the form of text. Okay, so here we need some data, we need some deep learning algorithm like a recurrent neural network, a transformer, and hybrid model. Now let us consider the recurrent neural network. Now recurrent neural network, this is a very basic algorithm which is used for the text data. Now let us consider one example, that is next word prediction, or language modeling to convert the language from one language to another language. We can use this recurrent neural network. There are different variants of the RNN, like LSTM, that is long short memory gated recurrent unit, or also we can use this long short memory in the two-way direction, that is a bidirectional LSTM. And these different variants we can use in different applications. Now next, transformer. Now in transformer, we are using the attention mechanism. Now the sequence to sequence task, that is a given input in the form of sequence and getting the output in the form of sequence. This task is performed by the encoder decoder, which is implemented with the help of recurrent neural network like LSTM GRU. And here, to improve the performance of the sequence to sequence model, we are using the attention mechanism. Now in attention mechanism, the contextual information with respect to the positional encoding with respect to the each word and sentence in a paragraph or in page, we are focusing on this contextual information and using this attention mechanism to improve the performance. Also, we can use the BERT, GPT, T5, such type of pre-trained model for the text processing. Next, last one, that is hybrid model. Now here we are using this text data along with the image data set. Suppose if you want to add some image captions in a given image. Now in this case, we can read the image. Okay, we can extract the information, contextual information using CNN model, and then pass through the RNN for processing the text image application. These are the different algorithms we can use for the text data set. Now let us discuss the implementation workflow. Now, whenever we are passing the data through any deep learning algorithm, then it is very important how we are processing this data. Now there are steps, then you need to follow the each and every phase properly, so that you will you will get the proper performance of your algorithm. First step, that is the image pre-processing. Data pre-processing. Whenever we are, now you are using the data in the form of image, video, or text format. Now whenever we are using the text, at that time you can use the tokenization, padding, stemming, these type of NLP pre-processing technique, which can be, you can complete with the help of NLTK tool or SPECI tool. There are again different n number of tools are available. You can use these tools for the pre-processing. Next, image pre-processing. The image processing, like resizing the image, cropping the image, normalization of the image, augmentation. Through the augmentation, we can generate the different types of images with different, using different image processing. You can convert one image into another format. You can create the mirror image of the original image, and in this way you can increase the number of data set. Next is the model training. Once your data pre-processing is completed, then we need to extract the features from the images, and then these features we can pass through the models. Then main task, how to decide the best model for your data set. Now you need to select the best deep learning algorithm for the text as well as the image. With respect to the significance of the deep learning algorithm, then you can select the algorithm for the your data set. Then hyperparameter tuning is very important. Now suppose if you are using the CNN for the classification of images, now in this case you need to set the value of the stride, you need to set the value of padding, filter size, all things you need to take care, you need to mention, and accordingly you need to check the performance of your selected algorithm. Next is the evaluation. In evaluation, the evaluation metrics are the different for the different tasks. If you are doing the classification for the images using CNN, at that time accuracy, precision, recall, F1 score, these parameters you can use. If you are using the machine translation example, that is translating language one language to another language, in this case you can use the blue score. If you are using implementing text summarization algorithm, in this case you can use the evaluation matrix, that is rouge. Okay, now based on your task, based on the data set, based on the type of algorithm, you can decide the evaluation matrix. Once you decide the evaluation matrix, then you can check the performance of your algorithm. Optimization is the last step, where you are trying to improve or optimize your algorithm. Now here in optimization, you can do the tasks like regularization. You can also update, or you can set some scheduling algorithm to reduce or decrease the learning rate to avoid the overfitting, and also you can add the dropout layer to reduce or increase the contribution of features of the neurons or neurons in your execution. Using dropout, you can deactivate some neurons or deactivate some features in a model. This is all about the implementation workflow. Now evaluation matrix for the image data, we'll discuss in brief. Evaluation matrix used for the every data set. Now here accuracy, already we are discussed. Whenever we are using image CNN for classification, accuracy we can check. Whenever we are extracting the multiple object, that is image recognition, at that time we can use the intersection over union, that is IOU parameter, as well as the mean average precision. These two evaluation metrics we can use for the multiple object recognition from the images. Already we have discussed the blue and rouge perplexity and confusion matrix, also you can use for the text data for evaluation purpose. Also you can display the performance of your model, selected model, using graph, training versus validation accuracy or loss, and comparison of the model matrix you can display, so that you can write some conclusion. Now let us discuss some insights and challenges whenever we are using the deep learning algorithm for our text and image data set. Inside effectiveness of the transfer learning or for the small data set, whenever data set is small, we are using selecting the option of transfer learning. That will give the better accuracy, and it will take the it require the less computational power, as well as the superior context understanding with transformer. Whenever we are using the transformer like BERT, again the computational power is less, because here we are using the pre-trained model for the calculating the attention score. Next, let us discuss the challenges. There are again different types of challenges, like high computational requirement. Whenever we are training high dimensional images on a GPU, it will require again more data, more capacity, computational power, and also the overfitting is occurred whenever we are using the small data set. The conclusion of this presentation, that is a summary of algorithm. We have discussed the different algorithms which is used for the image text, like CNN, GAN, transfer learning, RNN, and transformer. The key takeaway from this presentation: how to use the transformative impact of the attention mechanism, as well as the importance of the data quality and pre-processing. Next, the future direction. We can also use the multi-model for the image and text, as well as also you can use the mobile transformer for the image classification improvement. This is all about how to use the deep learning algorithm for the image as well as the text data set. Thank you.